Hello everyone. I will show you the simplest way to get a Tensorflow.keras classification model to train and then do a prediction with it. And all of this on your local machine. This will include setting up Python, because a broken Python is a great source of misery. Please have a look at the chapters to save yourself some time. This machine is completely clean to start with. Let's fire up the command line and type Python. That sends us to the store. Nice and all, but we like to choose our own version. So we hit the Windows key and type alias and open that settings menu. And there we disable that behavior. Okay, that's better. No Python found. Now we hop onto the World Wide Web and get us the latest Python version available. The latest version is also the wrong version at the time I am writing this script, but that gives me the opportunity to show you how to fix that properly. Because, let's face it, you do not have a clean Python 3.12 setup, now do you? No need for a custom installation, but we do need the Add Python to Pod option. Otherwise, we can't just type Python on the command line and expect it to know where it is. And we have a Python. Excellent. First thing we should and will do is update pip, which is Python's package manager. And now we install the TensorFlow package. No TensorFlow, but this is the latest Python there is. Yes, and that's the problem. Google has not completed their testing, or whatever it is they do, before releasing it to the newest Python version. So we need to get back to a previous version, which is 3.12. But first, we need to do a proper cleanup of the old version. Let me show you how to do that. That's gone. Now let's remove the launcher as well. A little more advanced, in the Explorer, go to %appdata%, go one folder up and enter local. So there we have some leftover pip files, and in the programs folder some remains of Python itself. They all need to go. If then, for any reasons, you still have problems, find the system and users variables. And clean any Python-related entries there also. Now the system is clean again. Great. Good skill to have when doing Python. Time to install the correct version. Make sure to choose the 64-bit version. I open a command line to triple check Python is really gone. Now install the 3.12 version. Python not found again? Yes. The part variable mentioned in the installer is loaded only when opening the command line. So reopening the command line will fix this. Once again, we upgrade pip. And install TensorFlow, which now is available and installing as it should. And done. Great. We are slowly getting where we want. Now open Python and from the command line import TensorFlow as TF. That will try to load the module with an alias, tf. And we get an error. Well, I do anyways, because my system is clean. If you don't, just skip ahead. The error tells us we need to install the Microsoft C++ redistributable, which is actually a common thing for programs to need. Just follow the link and install it. Yes, that's us, x64. Let's try loading TensorFlow again. And it is actually loaded. That is great. If you got this far, congrats. The hard part is over. Go get a coffee or something, the rest is almost guaranteed to work. I assume you already have some data you want to train on, and I don't want to share mine. So, let's get some from the internet. Kaggle.com is a nice site to find some datasets. Let's find some flowers. Everybody likes flowers, right? We got notebooks, topics, comments, and datasets. Yes, need that. I like this one. Been here for at all. Got 5 folders with images. Now go download. And we need to log in. Not what the button said, but understandable. Nothing was downloaded. This is where the download button becomes a lie. That's a very thin line you're walking, website. So just hit the download button again. And unpack it to the desktop. If we look inside the folder, we can see there are 5 subdirectories, one for each type of flower. Inside these are 1,000 images with various resolutions. That is enough for our model to get a good general idea of what each type of flower looks like. Okay, here we go. First Python script. This script is for checking our images folder for any files that can't be opened. That actually happens to me often. Like a thumbnail database file that's created after viewing the images. First we import CV2. That's short for Open Computer Vision version 2, a popular library for working with images and more. An empty list for all the images file names. Then a loop for plowing through all the files in the folder and adding the full path for those files to that list. And then a second loop to print the file and read the image from disk. If that fails, the last file printed is the offending one. The commented piece of code is to resize the images to a fixed size, to fit the classification model's input. But that is no longer needed nowadays. Let's run the code. And CV2 is not found. Let's install that over the command line. Now rerun the code. That's better. Every file is now read from disk as an image. And no problems found. Good for us. Second script. Training the model. Bam! Didn't see that one coming after all this slow stuff, did you? I will even do you one better than that. Starting the training and then explaining the code. You can see it's starting epoch 1 of 15, which means training cycles. There also is some sort of progress bar, but the console messes that up. Okay, the code. Right off the bat, we import TensorFlow with an alias tf. And then there are some Tensorflow.keras imports for designing the network. Please note there is also a keras as a separate package, almost identical. But we will use the one included inside the TensorFlow package. Again, the image folder. A batch size for when you are using a GPU. 128 is the number for a 3060 GPU. For CPU it doesn't matter that much. And then the image dimensions for the input of the detection model. Here we store a random number for splitting the image dataset into training and a validation part. That needs to be identical to not get an overlap. Then we have two blocks calling the same function to get the image dataset using that random number. The only difference is, in the first block we ask for the training set and in the second we ask for the validation set. The validation split is the ratio between the sets. 0.2 means there is 20% validation images and 80% training images. Printing out the class names, which basically means the subdirectories in the image folder. Just so you know, those are in alphabetical order. Always. Just remember that. We take note of the number of classes for constructing the network. Data augmentation, that is a part of the input side of the model used for training. Each time an image is read from disk, it is flipped, rotated or zoomed to give variation to the images as to not train to the exact images, but in a more generic way. Base model. Very important. You know those ready-made models that can classify 100 different objects? This is one of those. We cut off the head, which are those 100 classes, and keep the body, that does all the work. Here we state that we do not want the body to be retrained, only the rest of the model. If you have a very difficult classification to do, you can enable this, but training time will be much longer. Then we define the actual model. Yes, this will be our own creation. How cool! We have that augmentation input part and then some scaling of the images, which is why the input size of the images didn't matter anymore. Next, the base model, which will be static in this case. Some people already did some great work on that. And then we add new output layers. Just copy this, trust me, it works. Then we compile the model to get it ready for training. With an initial learning rate. Keep note of that. This is one of those things just to copy. It will decrease the learning rate over time. That helps to fit the model better. Set the number of training cycles here. If not retraining the entire model, this is a good number. Otherwise, make it 150 to start with. And here we kick off the training, which you can see happening at the left screen. Last line will explain itself, right? Model trained, model saved. Excellent. New script, final script. Let's do some actual classification. Almost same imports as before, but NumPy is new, but was already installed alongside with Tensorflow. We do the same, making a list of all the files like in the first script. Only then we choose a random item from that list and print it. That block is important. Training does not care much about import format, it handles that automatically. Prediction, however, we need to resize, change color format and change dimensions of the image array. Load the model we trained before. Also important, duh. And when we feed it, it needs to be an array of 1 images. Why? Because it can predict multiple images at once, but we only want 1. Same goes for the output. It returns us an array of outputs. But we will handle just the 1. For each prediction, it returns a list of probabilities for each class. We then find the highest value with argmax, which returns the index of that, which translates into folder number X, because alphabetical order, as you might remember. So let's run it. That's our image, right? And that is the array of probabilities. The first number is the highest. The first folder is Lily, which is where it got the file from. Amazing, isn't it? Thank you for watching.